For almost a decade now, one single architecture has been the undisputed king of AI, the Transformer. But its throne is definitely starting to wobble. So let's dive into the massive shift that's shaking up the entire world of artificial intelligence. Think about ChatGPT, or pretty much any AI app you use. Under the hood, a transformer is the engine making it all happen. But here's the thing. This king has a pretty big secret weakness, and it's a weakness that's seriously holding back what AI can become. So what even is a transformer? Well, Google first introduced it way back in 2017. Its superpower is a mechanism called attention, which is just a fancy way of saying it can understand how all the words in a sentence relate to each other. It was a massive breakthrough, for sure, but it came with a hidden cost. And that really gets us to the heart of the problem. I mean, what do you do when the reigning champ starts forgetting things and demands way too much power to do its job? This is what we're calling the Transformer's dilemma. And it is a big one. We're talking about two fundamental problems that have the smartest researchers in the world racing to find a replacement. Okay, so this breaks it down perfectly. On one hand, you have a huge scaling problem. The more data you feed a transformer, the more power and memory it just eats up. And it's not a gradual increase, it's exponential. It's kind of like a car that gets horribly inefficient the faster you go. Then, on the other hand, you've got the memory problem. Transformers are like that brilliant person who has, well, almost no long-term memory. They can't remember what you talked about at the beginning of a long conversation. And all of this adds up to what people in the industry are calling the transformer tax. It's this massive price in both energy and actual money that we have to pay for every single calculation these models make. And that kind of tax just isn't sustainable. It's exactly why the hunt is on for whatever comes next. So who are the main contenders trying to take the crown? First up, we've got an evolutionary approach from the original creators themselves, Google. They're calling it Titans, and the whole idea is to give AI a memory that works a little more like ours. Now, Google's not trying to throw the whole thing out. Their big idea is to evolve it. Titans introduces a dual memory system. You can think of the normal Transformer's attention as its short-term memory. What Titans adds is a new long-term memory to store the really important stuff. The analogy here is perfect. It's like upgrading a student from just cramming for a test to actually being able to take and consult their notes. Okay, but how does it know what's important enough to save? Well, this quote from their research paper nails it. Titans uses what it calls a surprise metric. Basically, if a new piece of information is unexpected, if it kind of breaks the pattern, the model tags it as surprising and therefore memorable. Then it gets stored away for later. All right, that's contender number one. Now for number two, and this one is totally different. This isn't an evolution, oh no, this is a full-on revolution. Let's talk about Liquid AI, a spin-off from MIT that's looking to replace the transformer completely. They call their creation a Liquid Foundation Model, or LFM. And instead of processing data as a series of discrete chunks, or tokens, they process it as a continuous, flowing stream. It's a radical new way of thinking, all based on the mathematics of change and motion. This is probably the best way to wrap your head around it. Transformers see the world like a series of still photographs. Snapshot, snapshot, snapshot. And they try to piece the story together. LLMs, on the other hand, see a continuous movie, a flowing river of information. And that simple shift, it changes everything about how they learn and, most importantly, how efficient they can be. And when I say efficient, I mean, wow, just look at these numbers. To process a long document, a transformer like Llama needs a whopping 48 gigs of memory. A liquid AI model of the same size, just 16 gigs. That is a massive difference. It's not just an improvement, it is a total game changer. So there you have it. Our two challengers are on the field. The evolution versus the revolution. Let's put them head to head and see how they stack up. This table sums it up beautifully. Google's philosophy is to fix the transformer. Liquid AI wants to replace it. Titans is still based on that expensive quadratic attention, while LFMs have linear complexity, meaning they scale way more efficiently. So what's the bottom line? Titans is designed for those heady-duty, long-reasoning tasks in the cloud, but LFMs are so efficient they're ideal for real-time AI running right on your phone or in a robot. So who's going to win? It almost doesn't matter which specific approach comes out on top. The bigger picture, as this quote points out, is that the era of a single AI architecture ruling everything, the monoculture of the transformer, is officially over. we're entering a new, much more diverse and exciting period for AI. So, what does this new era actually look like? Well, it's defined by a huge shift in how we even measure what makes an AI model good. For years, the AI race was all about scale. Bigger was always better. The only question anyone asked was, how many billions of parameters does your model have? That was the metric for success. But that's all changing. The new gold standard, the new key metric for success, is efficiency. It's all about how much actual intelligence you can squeeze out of every single watt of power you use. Okay, but why should you actually care about any of this? Because this shift from just brute force to smart efficiency unlocks a future that was basically science fiction until now. We're talking about powerful AI assistants that can run entirely on your phone, keeping your data private. We're talking about more responsive robots, truly smart cars, and a massive reduction in the environmental and financial cost of AI. It enables what some are calling sovereign AI, powerful models that can run on your own hardware, not just in some giant data center. And that leaves us with one last really fascinating question. For so long, AI has been this distant thing, living up in the cloud. As these new, super efficient architectures bring that intelligence down from the cloud and put it right into the device in your hand, what incredible new possibilities will we unlock? What are we not even imagining yet?